panel. We today did our last lesson of the unit. I told you this would be a really short unit. The next one I think is even shorter, but we unfortunately did not have enough days to be able to take the unit test before break. So you'll just have to remember everything and do well after break. So there's pros and cons to that. I would recommend at least do some of the IXL extra credit project points over break. That way you're kind of like staying sharp and consistent and not just forgetting everything. I do expect good scores from this unit test. Students tend to do better than they did like on unit 2 part 1 because this unit was really repetitive. Inequalities are only a little bit different. So I expect good scores, even though we are taking a week off for fall break. So with this lesson, you even had some time already in class to practice. Some of you might already be at that 80% or higher. What you should do is use this class period to make sure your binder check is ready. I will put out the practice test that I've not given anyone, so you would have had to come over here and grab it if you wanted it. But this is what I'll be making sure everyone gets on Monday. And this is what I'm also checking during the binder test. So why not just get it done now? Show it to me today so that those points can get entered already. You guys know that the 2 mandatory study guides, the ones that aren't extra credit, are worth assessment points in here. So no reason anyone should have a bad grade in math. You're just getting rewarded for doing the same stuff you're already supposed to do for algebra. So I'll put that out. You're welcome to come grab it. I really shouldn't see anyone just using the full hour as free time. Okay, I should see that you have an 80% on today's practice and that you did something else productive, like that paper study guide, so that you can get it done and not have to worry about it. All right, or get your notebook ready, things like that. There's lots of stuff in Schoology to help you prepare for the tests. So get that done too. You have been taught it all, that doesn't mean you understand it all yet, or we just need to practice it all. Questions? Okay, so then get to it. I'm here if you need me. Swims at an average rate 2.4 miles per hour, bikes at an average rate of 16.1 miles per hour. At the end of one training session, she has swum and biked more than 20 miles in total. This inequality and this graph represent the relationship between the hours of S, the hours of bike H, and the total distance the athlete could have traveled in. May said, I'm not sure the graph is right. For example, the 0.103 is in the shaded region, but it's not realistic for an athlete to swim for 10 hours and bike for 3 hours in the training session. I think triathlon athletes generally swim more than 2 hours a day. So it says, which one represents her last statement? So if you look at it, the only difference is the direction of the sign. And she said no more than 2 hours a day. So if what they're actually doing is on the left, S plus B, hours they're spending doing each. If it can be no more than 2 hours, can it be greater than 2 hours? So then we're going to pick the other one, the one that says it can be less than or equal to 2 hours. Then it says which graph shows the solution set to the original inequality and the inequality that represents her statement. So let's see. I'm seeing first if the dotted line is any different and it doesn't look like it. So it looks like we're just trying to plot May's. And her inequality had it as S plus B less than or equal to 2. in order to put it into something that I can graph, I'm gonna switch the S and B for X and Y. Would S be an X or a Y based on how these are labeled? And then B would be Y because of the axes. So then, honestly, just looking at it, I'm kind of leaning more toward the second one. Because this one is saying that at most they can have 4 hours of swimming, but that just doesn't really make sense. Like 4 would not be less than or equal to 2. So I'm already kind of leaning toward graph B because of that. But to really know, you'd probably want it in slope intercept form first. So it's going to be subtracting X on each side. And then we're looking for the one that has this line. So y-intercept of 2 and then going down 1 to the right 1, which this is not. So it has to be this one then instead. So graph B for the graph. And then it says, complete the following to determine a possible combination of swimming and biking times that meet both the distance and the time constraints in this situation. So half an hour of swimming. This is weird. There's some weird typos here. Okay, so I guess if they do half an hour of swimming and at most they can do 2 hours total, which one would it have to be then? $1.5, because that would be plugging it into the S plus B less than or equal to 2, and if I put a 2 here, that would be over the threshold, so it would have to be that one. I will fix it so it doesn't look so ugly, but that's what it should be. Let me make sure the key is right. Okay, so now it's correct. Questions on that? Okay, other questions? Serenity? Okay, 1 second. Okay, so a gardener is buying some topsoil and compost to fill his garden. His budget is $70. Topsoil costs $189 per cubic foot, and compost costs $459 per cubic foot. Select all statements of representations that correctly describe the gardener's constraints in this situation. So, lots of things. We just have to read each one and see if they're correct. I don't like how this is spaced though, so let me fix that. Okay. Okay. So the combination of 7.5 cubic feet of topsoil and 12 cubic feet of compost is within the gardener's budget. If the line, okay, so that next line is for something else. So we probably want to make the inequality first. What is the total in this situation? And if his budget is 70, can he spend more than 70? So then we're gonna flip that sign around. If his budget is 70, can he spend exactly 70? And then what goes here needs to contribute to that budget. So like if this is the total amount he has to spend, what goes on this side should be stuff that contributes to what's fine. So like these dollar amounts, so we can go with dollar amounts. How can I show the 1.89 for, pause real quick. I don't like the T and the C, especially if we're gonna look at a graph in a second. So based on how the graph is labeled, what do we want to make X represent? What is on the X-axis? So X will be for the cubic feet of the topsoil, and Y will be for the cubic feet of the compost. So I know it gave me different letters to use, but I'm going to use these because eventually I'll need to graph it. So when we talk about the cost, what expression needs to go here? So I just need to count how many feet of each, and that's, it just costs $1 per foot. Okay, good. And we're making sure that we put the correct prices with the correct variables. Normally they put it in the order of like how you read it. X usually comes first. But that would be a good way to. All right, so then if this is my inequality, that's what I can use to see if this combination works. So what I'm going to do is plug in the 7.5 for the topsoil, for the X, the 12 for the Y, and see if that's less than or equal to 7. And I'm sure you guys know how to use a calculator, at least I hope. So I'm just going to do it on my phone, and you can tell me if you got something different. So I have 14.175. Okay, so I got that he's spending $69.26. Is that less than or equal to 70? So then yes, it is less than or equal to 70. So I will pick that one. That is within his budget. It's not going over. Next we have the line represents this equation. This graph represents the solutions to the gardener's budget constraint. So it's not saying that the line is wrong. I know like it's saying an equation and this is an inequality. It's saying like this is graphed correctly, like it's not testing you on can you graph it. It's more like can you pick the right shading and the correct solid versus dashed. So let's look at the solid versus dashed first. If this was the symbol that we said, does that go with the solid line or dashed lines? So then don't pick this one. All right, next we have, sorry, it's really picky with the scrolling. Next we have this inequality. Does this match what we wrote aside from the variables? All right, this one actually has it facing the wrong way, so don't pick that one. That one says that what we spend can be greater than our budget, and we wouldn't want to do that. The next one says the combination of 5 cubic feet of topsoil and 20 cubic feet of compost is within the gardener's budget. So I would probably just plug it in and see what it totals and equals. That's what I'm going to do. Hopefully you know how to use a calculator. I would recommend to put it all in the calculator at once. That way you don't have to remember your order of operations. Okay, so
When I do that math in my calculator, I'm getting that he's spending $101.25, which is not less than or equal to 70. So we're not going to pick that one. Then it says this inequality, which aside from the variables, because we already switched it to X and Y so that we could read the graph better, it is the same as what we wrote otherwise. So that is correct. And then this graph, it's saying that the line is drawn right. We just need to make sure that it's correct as far as dashed or solid and shaded above or below. So we mentioned before, it should be a solid line. So that looks good so far. As far as whether it's shaded above or below, I mean, you can graph it in Desmos and see what it looks like. You can rearrange it to slope intercept form. At no point would I be multiplying or dividing a negative, so the sign wouldn't change directions. Or you can just think about it logically. We would not spend on this side of the budget. This side would be everything that is higher than our budget, so it would have to be below. So we would pick this graph that is solid and shaded below. And then that's all I think for this one. But you have to check every one and see that it's true. Make sure you're not just blindly picking. Make sure you're picking the ones that are exactly what I put. And then just those three. All right, other questions? Lana, question 5. Question 5 on this one. Okay, so Priya writes this equation, match each description with the equation that fits it. Okay, so an equation that has exactly one solution in common with her equation. So this is kind of a weird one. What I think is it wants you to graph it because they're equations. That's what I'm thinking. Why that's randomly showing up again, I don't know. But so let's graph the first given one. That's the one we're going to compare the rest to. And let's graph my first option. Okay. So this one, when we look at it on a graph, would it have one solution, no solution, or infinitely many? I don't know why I put a Z. Let me make that an X. No solution. So this one will go with this one that says no solution, right? So these ones are different. This one has one solution, no solution, infinitely many. So yeah, kind of more from the last unit, but that's okay. You should still know it. The next option, the y equals x minus 7, remember we're comparing it to this one. Don't get them like all mixed up. When I look at that, it intersects at one spot. So how many solutions is that? So then process of elimination, this one must be the infinitely many, but we can still check that graphically. The 12x plus y equals negative 7. And that one is infinitely many because when I graph it, it looks like it's just one line, but it's actually two. The blue one is right on top of the red one. All right, so there's that one. Let me make sure the key's right. All right, might have time for one more depending on how short it is. All right, Amy. Possibly. I don't know if we'll fit it in 2 minutes though. Do you think it's short enough? Okay, what number? Okay. So let's see. All right, so if you're making an inequality, what do I tell you to identify first? That's usually helpful. A total. So reading this, It says at least 100 square feet of painting. I'm not gonna put it like on this side because clearly they want the expression on the left since the symbol's here. So I'm gonna put it here on the right. It says at least 100. So which symbol would be for at least? Okay, so this one? Okay, the other way. All right, can it be equal to though? So then the one with the little line underneath. Okay. Which one sounds more like a rate of change and which one sounds more like a y-intercept? Yeah.
No, like,
5. Okay, so then that would have to go here, and then that means my y-intercept is the 25.